Alright, so here's my thinking was this whole thing. Put this here, slide this in, put a washer on here, and then tighten this down lightly, center this, and once this is centered, tighten it down really good. Put the table on the milling machine and mill my groove. Figure out where the cutter's going to fall, have the cutter come down, and then just zip. Now the question is this puny little setup I got here, is that going to be copacetic for what I want to do? Well, I'm trying to think about the kind of forces that are going to be exerted on this. If I were like drilling, I think there'd be more force being exerted that would be trying to twist this and rotate, make it rotate on its axis. So like if I was clamping it from the outside, it wants to spin. But if I'm going to be out here cutting a groove, there'll be some rotational force put out here. I think I'm going to be okay as long as I don't take too heavy of a cut, which I wasn't planning on doing anyways. It's only a high-speed steel 2-flute end mill. I wasn't going to try and hog out the whole groove in one shot. I could be real conservative. If this washer was a little thicker, that might not be a bad idea. Just because that washer's so thin, it wants to flex. I got this nice thick washer right here. It's even got ribs on it here to help it grip. But unfortunately, it's, ideally I want one with a hole in it the size for this bolt like this, and just larger. This is just large enough to cover the outside edge, so there's going to be very little of this gripping this. So what I'm going to do is I'm going to put this washer on first, then this washer, and tighten this up. And I'm still going to have room to run around there with my cutter. Alright, I'm going to have to be leaving soon. I don't know if I'm going to get back to this tonight. But if I could do one more thing before I leave, I would like to see whether or not I can center this on the table. Thinking of a way to do it. I could just use my calipers, but I'm actually thinking maybe a depth mic would be a better... Well, I think first I'll use the scale. Get in the ballpark with the scale, and then maybe I'll use a depth mic to get it like dead on. The other thing too is if I put it on the mill, and I'm just thinking outside the box here, or thinking out loud I should say, if I put it on the mill, I could put an indicator stand on the table of the mill, indicate this edge, and then rotate the table 360 degrees, and when I get no deviation on the reading, to me that would mean it's centered on the table, right? Yes? No? Okay. But let's get it close. Me and the mouse in my pocket, we're going to get this close first before we put it on the mill. Alright, right off the bat I can see we got a problem, because if I measure here, just eyeballing, it's 3 5/8, and I measure here, it's 3 3/8. So I need to go this way 1/8 of an inch. That's a little over 3 3/8, and that's still 3 and... Yeah, that's too much. All right, that's like 3 1/2. 3 1/2. That looks, eyeballing it, that's 3 1/2 dead on this way. Now let's see how we are this way. You can see it's off. Oh, maybe not. That's just over 3.5 there. Be close here too. Oh, I am. So that's actually close right there. And I gotta go wash up, and by the time I gotta go to wash up now, because by the time I get finished cleaning up and everything, it's gonna be time for me to go and pick up my kids. Well, I have several depth micrometer sets in various states of. Some of them are complete. Some of them have some surface rust on them because it's the way I found them. But tonight I'm going to use this Meditoyo set because it's in excellent shape and has all of the rods. And I do need a larger rod. Alright, I'll put the rotary table on the mill and then try that whole indicator trick I was thinking of attempting. Alright, so here's the setup. I bolted the rotary table down here to the left of my vise because I got my vise trammed and I don't really feel like taking it off and having to reset it. And I'm not really worried about the table being over here because I still have enough travel, because all I need to do is bring it over to about have this point under the spindle for the operations that I'm going to be doing. So I put my indicator stand right here on top of the vise, and I've got a Meditoyo indicator set up so that the point there is on the side of the thing. It's not exactly perpendicular, but that should be okay for what I'm doing. Basically, I'm looking at how much this edge moves in and out against the indicator as I rotate this. So I've already played with it a little bit and gotten it to the point where I found the high spot and I went 180 degrees around from that, and of course it was a low spot, and then I tapped it over to about half the amount of. I split the difference and tapped it over so the needle moved about half that amount. I repeated that a couple times. So I've gotten to the point now where I can go around 360 degrees and there's only maybe 1.5 to 2 thousandths run out total. And I'm going to stop there because that 1.5 to 2 thousandths, that could even be a slight out of roundness of this piece. So I'm going to see now whether or not I can tighten this down without messing up my reading too much. Okay, that's good. That's pretty tight, and the needle didn't move while I was doing that. One more quick check right here. This was not perfectly centered on the table. As I rotate the table throughout its 360 degrees, this needle, this reading would change. And definitely, as you can see, I was definitely on it. So, alright, so I'm satisfied now that the table is, that the part's centered on the table, and I've got this table bolted down securely. So now the next little bit of business is going to be to get this thing in position. Okay, now I want to figure out how to position the cutter, and I think the easiest way for me to go about doing this is to just figure out how far in the outside edge of this groove that I'm going to cut is from the outside edge of the whole piece. Now I can determine where I need it to be by the fact that I know that the OD of the piece is 3 inches. Well, it's actually 2 thousandths under 3 inches. I'm going to double check that right now. Yeah, it's 1 to 2 thousandths under 3 inches, depending on where exactly I place the caliper. So we can, I think I can discount that 1 to 2 thousandths or 1.5 thousandths or so, because I know that my slot is going to end up being wider than what it needs to be anyways because of my end mill. Let's just call this 3 inches. That's the OD. And the OD on this wheel is 2.730. 2.730. So if I subtract 2.730 from 3 inches, I get 270 thousandths. Is that correct? Let's see. Yeah, 270 thousandths. And then, so that's the difference between this diameter and this diameter is 270 thousandths, but we're dealing with this over here and this over here, so we divide the 270 thousandths by 2 and we get 135 thousandths. So the distance from here to here is 0.135. But because that cutter is going to be wider than this is a cast piece, so there's probably some imperfections in it. Let's call it 350 thousandths. The cutter width looks like it's 366. So 350 to 366, that's 16 thousandths difference. So if I want to take that extra 16 thousandths evenly on each side, then I want to push this outer edge over here actually out half of the 16 thousandths, which would be 8. So I want to subtract 8 thousandths from my 135, which will be 127. 0.127. Whoops, 27. 0.127. Okay. All right. That would be 27 plus 8 is 135. Got it. 127 thousandths. So if I bring my cutter up to the very edge here, okay, and then move it over 8 thousandths, that should put my cutter right where I want it. Oh, my mistake. I got to take it to count the diameter of the cutter. That's right. Okay. So 8 thousandths would move it over. Would move the edge of the cutter over to here, and then I want to move it over the width of the cutter. Right. Edge of the cutter here. 8 thousandths moves the edge of the cutter to here. And I want the edge of the cutter to be here. So the width of the cutter. Alright, so I put the spindle in neutral and bring the cutter down. And I got it in neutral so I could spin it with my hand. And I'm just gonna slowly bring this over until the cutter starts to rub. I should do it right there. Alright, it's just rubbing right there. So, get out of the way. We're gonna move this over 8 thousandths. I'll lock the table there for a second and just take a look at something. Yeah, that's what I thought. There's something wrong with my math. 8 thousandths isn't going to do anything. Alright, figured out my problem. I had 8,000 in my head for some reason. I used that calculation earlier. I need to get rid of that number, get that out of my head. 127 was what I was supposed to move in from the edge. That's the problem. 127. And then my cutter width, I just took the cutter out to double check it. It's 372. So, I'm going to do this again as far as getting this over. I want 127. I've got to raise the cutter up Alright, do that again. Get the cutter out of the way. So right there puts the leading edge of the cutter on the outside edge of the groove. So now I've got to go over the full width of the cutter, which I've decided is 372 thousandths. So I'm going to zero my dial, make my life easier. Right there, that's supposed to be it. Lock the table. Let's see where the cutter is. Looks like it might be it. Alright, so I'm going to take a light cut, real light cut, and then I'm going to measure that circle that gets cut and see if it's going to work. Actually, it doesn't look too bad. Oddly enough, if that bolt head wasn't in the way, I could actually drop this right in there and see. So if I did this right, this little edge right here should be 127 thousandths. It's actually such a it's such a shallow groove that I cut. I'm having trouble finding the edge. That feels like it right there. 130 thousandths. See if I can measure this. That looks like it's going to be 2 inches. Might need to be moved back out a little bit. Try and cut that a little bit deeper so I can get a better measurement. It's almost like there's a bevel at the edge there, or a little hill. So the easier thing to do is to set the calipers on the wheel, hand wheel OD, and then just see whether or not it'll fit. Doesn't look like it. The OD has to be larger. So I need to move the table back out just a smidge. Come out just a couple thousandths. Lock the table again. For the cutter that size, I think I want to be going a little faster on the RPMs. Alright, so I got a couple of clamps on here. Got this clamped down tight. Should be fine. Okay, so the next thing I want to do now is figure out exactly where I'm going to have this dial set for the first cut, and it looks like 90 degrees is a possibility. Alright, so if I center the cutter in this hole, I'm just eyeballing that. Alright, so that's at 25 degrees right now, so I should be able to run the cutter right down this line. So I just set my depth stop on the quill to just about where it touches off on the top of that surface, just above it. And what I'll do is I'll start the mill and I'll adjust that until it's just touching. And that has to be my first cut. That's 20 degrees, so now I need 100 degrees from there. now another 120 degrees. I was wondering what that noise was. My spindle's hitting this nut. There's a rookie mistake for you. So what I gotta do is reposition that clamp. Oh, my video card's almost full. Alright, the moment of truth. I do have a burr there. Okay, the alignment of the spokes looks good, but this still doesn't seem to be going down inside. Oh yeah, it is. Wow, that's really nice actually. This OD, the OD of this groove that I cut couldn't have been more spot on perfect. You can hear just a little bit of wiggle in there. Not going to make a damn bit of difference once all said and done. So now, got to work out some sort of a clamping system. This is just a piece of scrap that I found in the box here, but I'm thinking something like along the lines of this, a little piece of metal like this, maybe a little spacer in there, and, you know, drill and tap holes here, here, and, well, I'm only going to be able to put 2. Alright, so the next thing I want to do is I want to mill some flats on the back of the old handle here, so that when I put my clamp on here, it's going to basically be pushing on a nice flat area instead of this ridge that's right here. So I'm going to mill a flat here, and I'm going to mill a flat here. So what I'm doing is I'm kind of using my new knob as kind of a jig to hold this piece, the old wheel, and then I've got it clamped down. Now I can't put a lot of clamping force on here because I'm actually pushing on the 3 spokes. If I really tighten down on this too much, I'm going to easily snap the Zamek spokes, and then I'm going to really regret it. So what I'm going to do at this point is I've already zeroed it. I've got it centered on the table. So what I'm going to do now is I'm going to take some cuts, and I'm just going to take really light cuts so that I don't put a lot of force on this thing, because again, I've got it lightly clamped down.